Welcome to RSCH503, Research Methods and Biostatistics, a 3-credit graduate course offered by Drexel University College of Nursing and Health Professions. The two-way analysis of variance, or two-way ANOVA, is an extension of the simple one-way analysis of variance to the situation in which there are two independent variables and a dependent variable. For example, a psychiatric mental health provider is interested in studying concomitantly the effects of a certain drug and electroshock treatment in patients diagnosed with depression. As shown in this slide, there are two independent variables, shock and drug treatment, and the one dependent variable is the status of depression. The investigator can explore the main effect for shock treatment, the main effect for drug treatment, and the possible interaction effect of drug treatment by shock treatment on the dependent variable, state of depression. In a three-way analysis of variance, there are three independent variables and a dependent variable. Thus, there are 7 possible experimental questions to ask. 1. What are the main effects of each of the 3 independent variables? 2. What are the interaction effects of pairs of independent variables? That is, variable 1 with variable 2, variable 2 with variable 3, and variable 1 with variable 3. And lastly, what is the interaction effects of variables 1, 2, and 3 together? For example, what is the relationship between 3 independent variables, gender, course section, and upper or lower division of level student, on the dependent variable of course grade? To continue with this example, is there a main effect for gender? Is there a main effect for section? Is there a main effect for division? Is there a significant interaction between gender and section on grade? Is there a significant interaction between gender and division on grade? Is there a significant interaction between section and division on grade? And lastly, is there a significant gender by section by division effect on grade? A covariate is a continuous variable that is not a part of the main experimental manipulation but can influence the dependent variable. A covariate may also be defined as a variable that has a substantial correlation with the dependent variable and is included in this study to adjust the results for differences existing among subjects before the start of the study. In the example illustrated on this slide, the variance in libido is explored by examining the variance accounted for by Viagra, the independent variable, and the variance explained by covariates. The capital letter A is the basic ANOVA. The total variance in the dependent variable, libido, is partitioned into variance explained by Viagra and the unexplained or error variance. The capital letter B is the ideal situation for analysis of covariance. The covariate shares variance with the currently unexplained variance, but is independent from the treatment variance. That is, there is no overlapping variance. The capital letter C is the situation in which analysis of covariance should not be used because the effect of the covariate overlaps with the effect of Viagra. Thus, the Viagra effect is confounded by the effect of the covariate. Regression analysis is a statistical procedure for estimating relationships among variables. Regression analysis helps one understand how the typical value of a dependent variable, that is the criterion variable, changes when any one of the independent variables is varied, while the other independent variables are held fixed. It is a technique used for prediction and forecasting, for making more accurate inferences about a dependent variable from knowledge of an independent variable. Regression analysis is commonly used in health and social sciences, disciplines exploring the complexity of human behavior. Essentially, regression analysis enables variation in a given dependent variable to be understood due to concomitant variation in independent variables acting simultaneously. Simple linear regression can help an investigator determine the likelihood or probability that inferences are sound, and given a value for one variable, such simple linear regression can predict the most likely value for the other variable based on available knowledge of the independent variable. For example, examine the effect of anxiety on examination scores. We can attempt to predict the exam score from the anxiety score. The true exam score equals some constant plus coefficient x anxiety plus residual. The true exam score equals constant plus anxiety score plus residual. Multiple regression analysis shows the influence of two or more independent variables on a designated dependent variable. Example, in a study of postcardiotomy psychosis are ego, strength, and field dependence independence better predictors of postcardiotomy psychosis than either variable alone. In another example, are communication skills, mobility, sexual behaviors, and medication-seeking behaviors better predictors of effective community living than any other single variable alone? Statistical software programs can compute the multiple regression statistic, uppercase R, the multiple correlation between the dependent variable and the independent variables. R squared identifies that portion of the variance in the dependent variable that is accounted for by the independent variables. For example, in a study with one dependent variable and three independent variables, the R equals 0.616 and the R squared equals 0.380. The R squared indicates that 38% of the variance in the dependent variable is accounted for by the three independent variables. The odds ratio, capital O, capital R, is a measure of association between an exposure and an outcome. The OR represents the odds that an outcome will occur given a particular exposure, compared to the odds of the outcome occurring in the absence of that exposure. Or, put another way, when both the independent variable, that is, the predictor variable, and the dependent variable are dichotomous, the odds ratio may be used to indicate an association. The odds ratio is the ratio of the odds of an event occurring in one group to the odds of it occurring in another group. It is a way of comparing whether the odds of a certain event is the same for two groups. An example of an odds ratio is included in your textbook, pages 562 to 563. The research question is, what is the medical utilization pattern by homeless veterans receiving treatment in a VA healthcare system? To address this question, the investigator used the OR, odds ratio, using the chart in this slide. There are 4 cells. The formula to calculate the odds ratio is cells A times D are divided by cells C times B. In this case, the odds ratio indicated that homeless veterans have more than one ED visit as compared to non-homeless veterans. The chi-square statistical technique compares differences in proportions of nominal level variables. When a study requires a comparison between proportions, that is, percentages, in one category versus another category, the chi-square statistic reveals if the difference in proportion is statistically improbable. In one chi-square, if a one-way chi-square compares different levels of one variable only, for example, exploring gender only. A two-way chi-square test measures proportion in levels of one variable as compared to proportions of the second variable to determine statistical significance. For example, BMI and presence of colon polyps. In an example of chi-square test of independence, the question may be raised: what is the relationship between antibiotic use and candiduria in spinal cord injured patients? Again, the contingency table will have 4 cells. Those spinal cord injured patients with antibiotic use and candiduria, those with antibiotic use but no candiduria, those with no antibiotic use and candiduria, and those with no antibiotic use and no candiduria. The chi-square statistic obtained in this example suggested that antibiotic use might be a risk factor for developing candiduria. It is important to state that this session is a broad overview of statistical tests. Students are encouraged to review and to take additional courses in descriptive and inferential statistics at some time in their educational program. This presentation was prepared for graduate nursing students at Drexel University College of Nursing and Health Professions. The primary book used in this research course is The Practice of Nursing Research, Appraisal, Synthesis, and Generation of Evidence, 2017 edition by Jennifer R. Gray, Susan K. Grove, and Suzanne Sutherland. This book is published by Elsevier Saunders, St. Louis, Missouri.